Hi guys, question 9. It looks really complicated, but as long as you identify that when we're talking about real roots, you start thinking about the discriminant. Now, a real root means it can either be something like this, which has 2 roots, or it can be something like this that, that's just meant to, let's just colour that in, to just touch. And that means we have a repeated root. So, for example, a graph, this could be, for example, this, where the root would be -3. Okay, so in this situation, what we say is b squared minus 4ac is more than 0. So if you think back to your quadratic formula, this part, the discriminant, is more than 0. So therefore, we can also say b squared is more than 4ac. And here, this happens when b squared minus 4ac is equal to 0, and therefore we can say b squared is equal to 4ac. So it doesn't determine whether it's 2 or 1, so it can be either or. So what we're going to say is therefore b squared is more than or equal to 4ac. Okay, so all we have left to do now is just start putting some things in and see what happens. So b is the coefficient of x, so that's 8 squared is more than 4 lots of a, which is k, and c is 5. So we'll tidy this up. So we have 64 is greater than or equal to 20k. So let's just divide by 20. So 64 over 20 is 32 over 10, which is 3.2. Now, I can pop this round the other way as well. Okay, so that's it. You could, however, write 3 and a fifth. I'll pop that in there because I prefer fractions. But it was just easier with the way these numbers worked. Okay, so pretty straightforward when you know what to do. It's just identifying when to use the discriminant.